Hey, we're going to look, this is going to be, I bet you, mostly review. We're just going to look at how we do some simple arithmetic with polynomials, how we add and subtract polynomials. Very simple stuff. Multiplying polynomials you've done in the past. We might extend that a little bit today. And then we'll combine that stuff into some polynomial expressions that involve addition and subtraction and multiplication to simplify those. It's pretty straightforward, pretty simple stuff. We get a little bit of practice on the board. So when we're adding up polynomials, we already know how to do that. We're just adding like terms. So quick review of what it means to be a like term. What determines if two terms are like terms or not? Say it again. Same variables and same exponents, right? It has to be the same variables to the same powers. Very good. So for example, these would be like terms, right? They both involve x squared total. These would not. They both involve x's with the exponents. And if you, we won't do a lot of stuff with this, but sometimes you can have terms that involve multiple variables. Like, look at these are very complicated looking terms here. I mean, they've got x's, y's, and z's. Those would be like terms because they have exactly the same powers in each. Notice that the z and the y got mixed up here, but that doesn't matter. Right? Multiply stuff, we can always change the order in which we multiply it, right? Multiplication is commutative in this issue. Here would be examples of unlike terms. So, real quick, what would this look like if we were to combine to simplify? What could we do here? What terms are like terms? Looks like we got x squared y's. How many of those do we have? Show me with your fingers. How many terms do we have? Those x squared y terms. Looks like I got, yeah, two. Got one there and I've got one there. So those would go together. What is one of those plus 10 of those is how many of those? 11 of those. So we get 11 x squared y. Let's see about the x y's. I've got one there. I've got one there. So how many total do I have? Two plus 2xy's. And then let's see, I've got a negative 1y and a negative 2y, which combines to negative 3y. So minus 3y. Give me thumbs. How we doing? This is all you've done this stuff before. No big deal. Okay, so adding polynomials, it's just the easiest thing possible. You add polynomials, you literally just add like terms, combine like terms. That's it. When you subtract polynomials, it is just the tiniest bit harder, but insignificant. It's just as easy. All you do when you subtract polynomials is you're just going to distribute the negative signs and combine like terms and then add like terms. So, for example, if we're adding 3x minus 8 plus this quantity 4x squared minus 3x plus 3, do the parentheses really do anything here? They're unnecessary, aren't they? How come we don't need them here? Can somebody explain why? Why are they doing nothing essentially? What do you think? Yeah, because there's a plus sign, and so what number is really sitting out front there? One, and distributing one doesn't change anything, right? Multiplying something by one leaves it the same. So I really, first, what I would recommend when you're adding polynomials, if they're in parentheses like this, is just ignore the parentheses or erase the parentheses. You just don't write them. And then all we have to do is add like terms. So first step is remove parentheses and like terms. That's it, right? So what we got here looks like if I remove the parentheses, that's the first step. And then I've got some x's that are similar. I've got some constants, and I've got an x squared. Now, if I'm going to write the answer, the polynomial, in standard form, which term should I write first? The x squared, right? Because remember, when we write a polynomial in standard form, we want to put the biggest powers first. So we'd always group that one first. So the first thing we'd have is that 4x squared, which is a lot. There's only one term there, so that one stays the same. 4x squared goes first. And then look what happened a reminder, write it in standard form so we get the biggest powers first. Okay, if we're subtracting, it's only slightly different. What would I do here? Do I need the parentheses this time? I do. What do I need to do to get rid of the parentheses? I've got to distribute that negative, don't I? Right? I've got to distribute the negative 1. When I distribute a negative, I'm really distributing a negative. So we distribute the negative, which just changes all the signs. So what's that going to give me? Yeah, plus y plus 4. Good. Okay, and then if I add those up in standard form, what am I going to get? What goes first? Y plus 8. Got it. Okay. Thumbs. How we doing? He doesn't like work. No big deal. Okay, so what if we have a big expression like this? Okay, tell you what, why don't you go to the board and give it a try? Okay, here we go. So that looked pretty good. Looked pretty good. What do we do here? We're just going to distribute the negative here to get rid of the parentheses. Those parentheses I can just get rid of, right? Because there's just a 1 out front, nothing to distribute. These, the third polynomial, I can just erase the parentheses. They're unnecessary, so we end up with that when we distribute the negative. And now it's just a matter of combining like terms. Everybody got that? We've got to do the a squareds first. So I've got -1, -2 plus 5 would give me a +3, right? And then what about the a's? I've just got a -6a. That's the only a term, so that one we leave alone. 1 plus 3 is 4, plus 7 is 11. We got it. Okay. Give me thumbs. Looked like that was pretty good. Okay. Good stuff. All right, what about multiplying? So we've already done a bunch of this. The first example is something that we essentially have already dealt with. This is really just properties of exponents. When we multiply two monomials, which is just a single term polynomial, you already know how to do that. We just sort of group things, right? We're going to multiply the numbers first, and then we're going to multiply the x's. So we end up with -6 and then x squared times x to the 1. Remind me real quick, property of exponents. Multiply like bases. What do we do to the exponents? We add the exponents. And what's the exponent for that one? 1. So x to the 2 times x to the 1 is x to the 1 plus 2, 3. Okay, what happens if we've got multiple kinds of variables? That's all right. We would just do the same thing. We're just going to put the numbers first. +6 times -1 gives us a -6. Then come the x's. Then come the y's. Then come the z's. Same exact approach. Okay. Now, what happens if we're multiplying polynomials that aren't both monomials? Like, what do we do here? If I'm multiplying 4x squared times this trinomial, all I do is distribute. Right? I just distribute to each part. So when I distribute to the first term, I'm going to do the same thing. 4 times 3 is 12. X squared times x squared is x to the 4, and so on. Just distribute to each term. Okay, give me fist to 5 on that one. How we doing? That stuff's all old hat. Okay, if we're going to multiply two bigger polynomials together, again, you just distribute. Now, what I recommend you do, just to be consistent, I always distribute, well, distribute from the first polynomial when that's convenient. But in general, I think it's easier to distribute fewer times. So, for example, if we were going to multiply something like this together, I've got a binomial times a trinomial. To me, it's always easier to just distribute from the polynomial that has fewer terms, so you only have to distribute twice instead of 3 times. The answer's going to be the same. Does that make sense? Okay, I mean, you can do it either way. But seems simple. Okay, so let's go through this one step by step. What am I going to distribute first? 2x. Okay, so help me out with that. 2x gets distributed there. What's that going to give me? 14x squared. Good. 2 times 7 is 14. X times x is x squared. So we get 14x squared. 2x times 5. Everybody, what is that? 10x. Good. And then we distribute what here? Say it again. Negative 4, not 4, right? We have to distribute the negative sign also, so we get the whole thing. We're going to distribute the negative 4 gets distributed to both parts also. So negative 4 times 7x is negative 28x. Negative 4 times positive 5, negative 20. And then what? Combine like terms. Good. So I've got to combine those x's. And 10x minus 28x is negative 18x, and we got it. Okay? You guys remember this stuff, right? What if you had something big like that? That's no big deal. You just have to distribute 3 times instead of twice. No big deal. So they both have 3, the polynomial, so it doesn't really make any difference which one we start with. We'll just distribute from the first one to the second one. What do I distribute first? 2x squared. So I have to distribute it to each term. I agree, that's what you get. Take a look at that. Give me thumbs. You agree? Does that all make sense? Okay, what gets distributed next? X, right? 1x, good. So distribute this guy. First term going to be x times x squared, x cubed. Next term, 3x squared. And last one, x times 4, 4x. Okay, and then finally, last thing I distribute is what? Negative 1. Negative 1 times x squared. Negative x squared. Negative 1 times 3x. Negative 1 times 4. Good. And then last thing is just combine like terms, right? We can just kind of check them off as we go. What's the first term going to be in my answer? 2x to the 4. There you go. We'll just kind of check those. Just kind of check that one off. Just underline it as we go. So that one. What's next? All the x cubes. So how many x cubes have we got? 6x cubed plus x cubed is how many x cubes? 7. Then we've got, looks like x squareds, right? So 8x squared plus 3x squared minus 1x squared. What's that? 10x squared, I agree. We got the x's plus 4x minus 3x plus x plus 1x, right? We don't write the 1, plus x. And then finally, we've just got that last term by itself, that negative 4. We got it, right? Okay. So I want to show you a little trick here that makes this a little bit easier. Did you notice on this last example, the really inconvenient part of this very simple process really inconvenient part is you end up with this long string of a bunch of terms. And if you're going to make a simple mistake, it's likely to be when you're just combining like terms, because you might forget one or something. Okay? So here's a way to organize the process. So organize, when you do your distribution, organize the answers into columns. Okay? What's going to be, you can already predict here when I do my distribution, be the biggest power of W in this answer. W cubed, right? And you know it's going to be when you distribute the leading term of the first polynomial to the leading term of the second polynomial. That's going to give you the biggest leading term of your answer, right? So you know you're going to get a W cubed. So then here's how you can organize the way you do this. You're just going to set up a bunch of columns for each power of W, starting at W cubed, and then you're just going to work your way down all the way down to the constant. And you don't even have to write it out. Just in your mind, you've got these columns. So when you do your distribution, you can place the answers into the correct column. You can add up the like terms vertically. It's way easier than that. So when we distribute the W times W squared is W cubed. W times 2W is 2W squared. W times 1 is positive W, right? When I distribute the negative 7, negative 7 times W squared is negative 7W squared. So where's that one go? Yeah, that column doesn't line it up with the W squared. Minus 7W squared. Negative, minus 7 times 2W is minus 14W. Negative 7 times 1 is negative 7. And all I have to do now is just add up the columns vertically. It makes it real organized and easy. So I get W cubed, 2W squared minus 7W squared is how many? Negative 5. So minus 5W squared. W minus 14W is 13W. And I've got a minus 7. Okay, better, right? Makes it easier. Give me thumbs. Does that make sense? Okay. So once you guys go, try with this. Oh, and by the way, real quick, before you jump into this one, what are you going to do this time? What if you're multiplying? I kind of threw a curveball at you, but you can do this. Yeah, you bet. What are you going to do here? If you're multiplying three polynomials together, you have to do them how many at a time? Well, I mean, you can only do two at a time, right? So we're going to have to multiply two of them, simplify that, and then distribute the third one, right? Would you agree? Okay, now my recommendation is that negative 3 that's out front, wait till the end to distribute that. There's no reason to distribute that one last, so you keep the number small. Make sense? Okay, go. Yes. Okay, so this is a good one to kind of work through once on your own. Now we'll talk about it. So when you see stuff like this, when there's how many total on your fingers, how many total things are being multiplied together? How many factors? Yeah, there's four things, right? What are they? Negative 3 times the quantity a plus 5 times the quantity a minus 2 times the quantity a plus 8. So the thing is, when you're multiplying multiple things together, you just have to do it in small pieces, right? You just have to do it step by step. So we would start off multiplying two of these together. Let's just take, for example, what if we multiply these together first? So I distribute the a times the a, and I get a squared. A times a plus 8a. Negative 2 times a, negative 2a. Negative 2 times 8, negative 16. I add those up, and I get a squared plus 6a minus 16. There's one step done. Now I've got to multiply the next part. So I bring down this other stuff. distribute the a plus 5, how about? If I distribute the a, I'm going to get what? A cubed plus 6a squared minus 16a. And look how we're lining stuff up vertically. It makes it easier. Plus 5 squared plus 30a minus 80. Add all that stuff up. We got a cubed. How many a squareds? 11. Good. Negative 16 plus 30, 14. Okay, last step. Got to distribute that negative 3, which is just going to give us negative 3a cubed minus 33a squared minus 42a plus 240. And you just got to take it step by step. All right, last thing, I just wanted to show you one quick example. You can also, if you want to, you can also multiply polynomials using like long multiplication like you used to do back in the day with multi-digit numbers. If you just write out the polynomials and you have columns for all the powers of x, look how this works. If I multiply the 9 through first, 9 times 9 is 81. 9 times 5x, 45x. So that's a positive 81 right there. We get a positive 45x. 9 times 2x squared, 18x squared. Okay, then I can multiply the 7x, but now I'm starting in the x column. 7x times 9, 63x. Look how it lines everything up then, right? 7x times 5x, 35x squared, good. And then finally 7x times 2x. And look, then everything's automatically lined up vertically. So if you want to do it this way, I mean, most people probably don't, but if you want to, you can use this vertical multiplication also. Add up like terms. 45 plus 63, what is that? 108. 18x squared plus 35x squared, 53, good. And I've got 14x cubed. Good enough? Okay, that's it. Do we have any time? Oh, 8 minutes. Go for it. Simon's up. See if you can get a few done.